without ever thinking about the invisible systems keeping the city alive. From underground flood tunnels to massive power grids and perfectly timed supply chains, an entire hidden world operates around the clock beneath the surface. Today, we're taking a closer look at the extraordinary systems that make one of the world's largest cities function every single day. Before most people in Tokyo even open their eyes, the city has already been awake for hours. Millions of lights are glowing in apartment towers. Trains are being prepared for the morning rush. Convenience stores are restocking shelves. Fresh fish is arriving from ports hundreds of miles away. Office buildings are adjusting their air conditioning before the first employees walk through the doors. Everything appears effortless, almost automatic. But the truth is that Tokyo is not simply a city.
It is a machine made of countless hidden systems that have to work together every second of every day. If just one of those systems stops for long enough, the consequences begin spreading much faster than most people realize. What makes Tokyo remarkable isn't just its size or its population. It's the fact that nearly 40 million people depend on an invisible network that almost nobody notices until something goes wrong. The streets may look calm, the trains may arrive exactly on time, and the skyline may seem permanent, but underneath that ordinary surface is one of the most complicated urban survival systems ever built by humans. Every minute of every day, thousands of different organizations, engineers, operators, technicians, drivers, computers, sensors, and emergency teams are quietly keeping the city alive. Most residents never think about them.
They simply assume the water will come out of the faucet, the electricity will stay on, the trains will arrive, and the elevators will work. But none of those things happen by accident. They happen because millions of tiny decisions are constantly being made behind the scenes. Tokyo is often described as one of the safest and most efficient cities on Earth, yet its greatest achievement may actually be something much less visible. It has learned how to survive despite living in one of the most dangerous places imaginable. The city sits near major tectonic plate boundaries where powerful earthquakes are not a possibility, but an expectation. Every year, thousands of small earthquakes shake the region. Most people barely notice them anymore. The buildings sway gently, dishes rattle for a few seconds, and life continues. That calm reaction hides decades of preparation. Engineers know that the question has never been whether another devastating earthquake will happen.
The only unknown is when. That single reality influences almost every hidden system inside the city. It affects how skyscrapers are built, where hospitals are located, how roads are designed, where fuel is stored, how communication networks operate, and even how drinking water is distributed. Nothing is left to chance, because the cost of failure would be enormous. Yet earthquakes are only one threat. Tokyo must also prepare for typhoons, floods, heat waves, heavy snowfall in surrounding regions, cyber attacks, power shortages, and supply chain disruptions. Each danger interacts with the others in ways that are difficult to predict. A damaged railway can delay food deliveries. A flooded substation can interrupt communication networks. A communication failure can slow emergency responses. Every hidden system depends on several others. That means resilience isn't created by making one system stronger. It comes from building thousands of overlapping backups that quietly protect one another. One of the clearest examples can be found beneath the city's streets. Most visitors think Tokyo's underground world consists only of subway stations and shopping malls. In reality, those are only the visible parts of a much larger network. Below the sidewalks lies an extraordinary maze of tunnels carrying electricity, drinking water, natural gas, fiber optic cables, sewage, stormwater, district heating pipes, and countless maintenance corridors. Many of these tunnels are large enough for workers to drive small vehicles through them. Others are monitored by sensors that constantly measure pressure, temperature, vibration, and water flow. If a pipe begins leaking, operators often know long before anyone above ground notices a problem. Engineers can isolate damaged sections while redirecting service through alternative routes.
In many neighborhoods, residents never even realize repairs are taking place beneath their feet. This hidden flexibility is one reason why Tokyo can recover from disruptions much faster than many other megacities. But even these underground systems rely on something else. They need electricity. Without power, pumps stop moving water, ventilation systems shut down, communication equipment loses connectivity, traffic signals fail, elevators stop operating, and refrigeration systems begin warming. Electricity is the invisible heartbeat connecting nearly every other system inside the city. Unlike many people imagine, power doesn't simply travel directly from one giant power plant into every building. Tokyo's electrical network is an enormous balancing act. At every moment, engineers must match electricity production with electricity demand almost perfectly. Unlike water or gasoline, electricity cannot easily be stored in massive quantities using traditional methods.
Supply and demand must remain balanced continuously. If demand suddenly rises because millions of people switch on air conditioners during an intense summer afternoon, additional power must immediately enter the grid. If demand suddenly falls, production must decrease just as quickly. This balancing process happens every second through an intricate network of power stations, substations, transmission lines, automated controls, and human operators watching enormous monitoring screens around the clock. Even tiny changes ripple through the system. A single major industrial facility starting up can alter demand. A cloud passing over large solar installations changes production. Temperature shifts influence household energy use across entire districts. Modern software constantly predicts these changes, but experienced engineers still play an essential role in making decisions when unexpected situations develop. Tokyo's electrical system also learned painful lessons from past disasters.
After the 2011 earthquake and tsunami damaged energy infrastructure across eastern Japan, rolling blackouts forced many people to reconsider something they had rarely questioned before. Electricity suddenly became visible because its absence affected nearly every aspect of daily life. Since then, enormous investments have been made to strengthen the resilience of the grid. Backup generators became more common. Energy-saving technologies spread rapidly. Buildings improved their emergency systems. Battery storage expanded. Critical facilities such as hospitals, transportation centers, communication hubs, and government buildings developed more independent sources of electricity. Some districts can temporarily isolate themselves from wider grid failures, allowing essential services to continue even if surrounding areas lose power. This layered approach means Tokyo no longer relies on a single solution. Instead, it depends on many smaller systems supporting one another simultaneously.
Yet electricity alone cannot keep a city alive. Even with unlimited power, a modern metropolis would quickly collapse without another resource that most people barely think about until it disappears. Every day, millions of people in Tokyo expect perfectly clean drinking water to flow instantly whenever they turn a faucet. They wash clothes, cook meals, flush toilets, clean hospitals, manufacture electronics, fight fires, cool industrial equipment, and maintain public sanitation without considering where that water actually comes from. Behind that simple expectation lies another hidden system so vast that it stretches far beyond the city itself. Reservoirs in distant mountains, rivers flowing across multiple prefectures, massive treatment facilities, pumping stations, underground reservoirs, pressure control systems, and thousands of miles of pipelines all work together with astonishing precision.
The water entering a kitchen sink in central Tokyo may have traveled through several completely different systems before reaching its final destination. Every stage is monitored continuously because contamination, pressure loss, or equipment failure in one location could eventually affect millions of people hours later. The city doesn't simply distribute water. It constantly predicts demand, manages storage, detects leaks, balances pressure, and prepares for emergencies that may never happen. Even then, this entire network depends on countless workers who spend their careers maintaining infrastructure that most residents will never see. Water distribution is only half of the story. Every gallon that enters Tokyo eventually has to leave again, and that creates another hidden system that is just as important as the one delivering clean water. Most people never stop to think about what happens after they flush a toilet, drain a sink, or watch rain disappear into a storm drain.
They simply expect it to vanish. In reality, that disappearing act depends on one of the largest underground engineering networks ever constructed. Thousands of miles of sewer pipes stretch beneath neighborhoods, connecting homes, apartment towers, offices, factories, schools, and hospitals to enormous treatment plants that operate around the clock. Gravity does much of the work, but not all of it. Massive pumping stations lift wastewater whenever the terrain changes, moving millions of gallons every single day without interruption. Sensors constantly monitor water levels, flow rates, and pressure. If one section begins to clog or overflow, operators can often redirect flow before streets above show any sign of trouble. During ordinary weather, the system works almost invisibly. During heavy storms, however, it faces one of its greatest challenges. Tokyo experiences powerful typhoons that can dump extraordinary amounts of rain in just a few hours.
In a city covered by concrete, asphalt, rooftops, and pavement, rainwater cannot simply soak into the ground. Instead, it races toward drains, canals, and rivers at incredible speed. Without protection, entire districts could flood within hours. To prevent that from happening, Tokyo built an underground flood defense system, unlike almost anything else in the world. Deep beneath the suburbs lies a network of enormous tunnels, vertical shafts, and giant storage chambers designed to temporarily hold floodwater before releasing it safely into nearby rivers once water levels fall. Some of these underground chambers are so large that visitors often compare them to enormous cathedral halls supported by towering concrete columns. Standing inside them makes it difficult to believe they exist beneath ordinary streets lined with homes and convenience stores. During severe storms, water rushes into these chambers instead of flooding neighborhoods.
Giant pumps then move astonishing volumes of water back into rivers once conditions become safe. The entire process happens largely out of sight, allowing life above ground to continue with surprisingly little disruption, considering the amount of water involved. But those flood defenses depend on accurate information arriving long before the rain does. Meteorologists, river authorities, emergency managers, and infrastructure operators constantly exchange data. Weather satellites monitor developing storm systems over the Pacific Ocean. Radar tracks rainfall intensity almost minute by minute. River sensors measure changing water levels. Computer models estimate where flooding may occur hours before the first streets become threatened. Those predictions allow operators to prepare pumps, lower reservoir levels, inspect drainage systems, and position emergency crews before conditions deteriorate.
The system succeeds not because one machine is especially powerful, but because thousands of smaller pieces share information continuously. If communication slows, every decision becomes harder. If forecasts arrive late, valuable preparation time disappears. Information itself becomes a form of infrastructure. That dependence on information extends far beyond weather forecasting. Nearly every hidden system keeping Tokyo alive relies on communication networks that most people never notice. Fiber optic cables buried beneath streets carry enormous amounts of data between government agencies, transportation companies, hospitals, financial institutions, utility providers, and emergency services. Mobile phone towers blanket the metropolitan area, allowing millions of devices to remain connected simultaneously. Data centers process staggering amounts of information every second, monitoring everything from train schedules to electrical demand and traffic congestion.
Many intersections automatically adjust signal timing depending on vehicle flow. Railway operators receive live information about train positions down to remarkably small margins. Utility companies monitor equipment scattered across hundreds of square miles without sending workers to inspect every location manually. The modern city functions because information moves almost as efficiently as electricity or water. Cybersecurity has therefore become just as important as physical maintenance. A damaged pipe can interrupt water service, but a compromised computer network could potentially affect multiple systems at once. Utility providers now defend against digital attacks with the same seriousness that engineers once reserved only for earthquakes and fires. Critical infrastructure is increasingly isolated from public internet connections. Multiple backup communication paths exist in case one network fails.
Control centers regularly simulate emergencies, ranging from natural disasters to coordinated cyber incidents. Staff members practice operating essential systems manually if automated controls become unavailable. These preparations rarely make headlines because successful security often looks like nothing happened at all. The public simply experiences another ordinary day, while countless invisible safeguards quietly perform their job. Perhaps nowhere is this coordination more impressive than inside Tokyo's railway network. To many visitors, the trains seem almost impossibly punctual. A delay of only a few minutes can generate formal apologies from railway companies because passengers have come to expect extraordinary precision. That level of reliability is not achieved simply by asking drivers to arrive on time.
Behind every departing train is an enormous organization involving maintenance crews, dispatchers, control centers, cleaners, station staff, engineers, electricians, inspectors, software systems, and thousands of workers whose names passengers will never know. Tracks are inspected constantly, often during the few overnight hours when trains stop running. Specialized vehicles measure tiny imperfections in rails before they become dangerous. Signals communicate continuously with approaching trains, maintaining safe distances automatically. Power systems are divided into sections, so problems in one area do not necessarily shut down the entire network. Every morning, millions of passengers step aboard expecting everything to function perfectly. Most never realize how many separate hidden systems had to succeed before that first train even left the station.
Tokyo's railway network, however, is only the visible layer of a much larger logistics system that determines whether the city can actually function from one day to the next. Every morning, millions of commuters step onto trains carrying nothing more than a briefcase or a backpack, rarely thinking about the millions of tons of goods that also have to move across the metropolitan area every single day. Food, medicine, fuel, construction materials, replacement parts, clothing, electronics, medical supplies, restaurant ingredients, and household products all have to arrive at exactly the right place, often within remarkably small delivery windows. Unlike many cities that rely on large warehouses packed with weeks of inventory, Tokyo operates with an extraordinary level of precision. Space is limited, land is expensive, and businesses often store only what they expect to sell in the near future. That means delivery trucks are not simply bringing new products.
They are replacing products that have already been sold. Every delayed shipment begins creating consequences that spread far beyond a single business. A restaurant waiting for fresh seafood may not be able to serve its full menu. A hospital missing a shipment of specialized equipment may need to postpone procedures. A factory waiting for one small electronic component may stop an entire production line. The city depends on movement just as much as it depends on electricity or water. Much of that movement begins long before delivery trucks enter the city. Tokyo is connected to an enormous national and international supply network that stretches across oceans, ports, highways, rail corridors, airports, and industrial centers. Every day, cargo ships arrive carrying containers filled with products manufactured thousands of miles away. Ports unload those containers using highly coordinated systems that operate almost continuously.
Cranes move cargo with incredible efficiency, while customs officials, freight companies, logistics operators, and transportation planners ensure that shipments continue moving instead of remaining stacked at the docks. From there, freight trains, cargo trucks, and distribution centers divide those shipments into smaller loads destined for individual neighborhoods. Timing is everything. Roads become heavily congested during certain hours, so deliveries are carefully scheduled to minimize delays. Many businesses receive shipments early in the morning before customers even arrive. Others depend on nighttime logistics when highways are less crowded. Every hour of the day has been carefully integrated into a transportation rhythm that most residents never notice. Convenience stores provide one of the clearest examples of this hidden efficiency. They appear almost magical in their consistency.
No matter what time someone walks inside, shelves are usually stocked with fresh meals, drinks, snacks, household supplies, and countless other products. That appearance of abundance is maintained by an astonishing logistical operation. Individual stores often receive several deliveries every day instead of one large shipment every week. Fresh food arrives separately from frozen products. Newspapers, beverages, prepared meals, and packaged goods each follow their own carefully organized schedules. Computer systems continuously analyze sales patterns, allowing managers to predict how much inventory should arrive before customers even realize supplies are running low. Rather than storing large quantities in back rooms, stores rely on constant replenishment. The shelves themselves become part of the supply chain. If transportation slows significantly, empty spaces begin appearing much sooner than many people would expect.
Food distribution is especially sensitive because Tokyo consumes enormous quantities every day. Millions of meals are prepared across restaurants, schools, hospitals, offices, and homes, requiring an uninterrupted flow of ingredients from every corner of Japan and from countries around the world. Seafood arrives from coastal fishing ports. Vegetables travel from farming regions hundreds of miles away. Rice, meat, fruit, dairy products, and cooking oils move through specialized refrigerated networks designed to preserve freshness throughout the journey. Temperature control is maintained from the moment products leave processing facilities until they reach supermarket shelves. Refrigerated warehouses, insulated trucks, cooling systems, and continuous monitoring all work together to prevent spoilage. Even brief equipment failures can ruin entire shipments.
That is why backup generators, emergency maintenance teams, and multiple transportation options have become standard throughout the cold chain. Freshness is not simply the result of fast transportation. It depends on thousands of hidden decisions made long before food reaches consumers. Waste moves through the city with equal importance, although far fewer people ever think about it. Every single day, Tokyo generates enormous amounts of garbage from homes, businesses, restaurants, offices, construction sites, hospitals, and industrial facilities. If that waste remained on the streets for only a short time, public health, transportation, and everyday life would deteriorate rapidly. Instead, an elaborate collection system quietly removes it with remarkable consistency. Different categories of waste are collected on different schedules. Residents separate recyclable materials, burnable waste, plastics, glass, metals, and oversized items according to carefully established rules.
Collection vehicles follow highly optimized routes designed to maximize efficiency while minimizing traffic disruption. Behind those collection trucks lies another network of sorting centers, recycling facilities, waste-to-energy plants, and disposal sites that process millions of tons every year. Much of the city's waste is not simply buried. Advanced incineration facilities reduce its volume while generating electricity and heat that can be fed back into surrounding communities. Even garbage becomes another resource inside Tokyo's carefully interconnected urban ecosystem. This philosophy of maximizing every available resource extends into the city's buildings themselves. Modern skyscrapers are no longer passive structures that simply provide office space or apartments. Many function as sophisticated systems capable of responding dynamically to changing conditions.
Sensors monitor structural movement, indoor air quality, energy consumption, water usage, occupancy levels, and temperature throughout the day. Elevators automatically adjust to expected passenger traffic. Ventilation systems reduce energy consumption in unused areas while maintaining comfortable conditions where people are present. Some buildings store emergency water supplies, backup electricity, and communication equipment capable of supporting occupants during disasters. Others incorporate seismic isolation systems that allow entire structures to move independently from the ground beneath them during earthquakes. To someone walking past on the sidewalk, these towers appear perfectly still. In reality, many are constantly making thousands of small adjustments every hour, quietly adapting to both human activity and the natural forces surrounding them. Each building has become another intelligent component inside the much larger machine that keeps Tokyo alive.
The deeper you look into Tokyo, the clearer it becomes that the city is constantly preparing for events that may not happen for years or even decades. This philosophy shapes nearly every decision involving infrastructure, transportation, communications, and public safety. Instead of assuming that normal conditions will continue indefinitely, planners begin with the opposite assumption. They ask what happens when multiple systems fail at the same time. What if a major earthquake strikes during the morning rush hour? What if a powerful typhoon arrives only days later? What if power outages affect communication networks while hospitals are already operating under emergency conditions? These are not theoretical discussions held once and forgotten.
Government agencies, private companies, emergency responders, utility operators, railway organizations, hospitals, and local communities regularly participate in coordinated disaster exercises that simulate situations far more complicated than a single emergency. Every participant already knows that no organization can protect the city alone. Success depends entirely on thousands of separate groups responding together with remarkable speed and precision. Hospitals represent one of the most carefully protected parts of this hidden network. A modern hospital cannot simply continue operating because doctors and nurses remain inside the building. It requires electricity for life support equipment, oxygen systems, diagnostic imaging, operating rooms, refrigeration for medicines, electronic medical records, elevators, ventilation systems, sterilization equipment, and communications.
It also needs clean water, reliable transportation, fuel for emergency generators, food supplies for patients and staff, medical gases, pharmaceuticals, laboratory materials, and continuous deliveries from outside suppliers. Every one of those requirements depends on another hidden system functioning correctly. Because of this, many hospitals maintain extensive backup infrastructure designed to operate independently for significant periods if outside services become unavailable. Fuel tanks are protected. Emergency generators are tested regularly. Medical supplies are carefully managed to ensure that essential treatments can continue even during widespread disruptions. Some facilities even maintain redundant communication systems so they can remain connected if conventional networks become overloaded or damaged. Patients may never notice these preparations, but they become invaluable during emergencies when every minute matters. The same philosophy extends to the city's fire departments and emergency services. Responding quickly in a metropolis of Tokyo's size requires much more than placing fire stations throughout the city. Emergency vehicles rely on constantly updated traffic information, carefully planned station locations, specialized equipment, and communication systems capable of coordinating thousands of personnel simultaneously. Dispatch centers receive emergency calls, identify locations within seconds, determine the closest available units, monitor traffic conditions, and continuously update responders as situations develop. Advanced mapping systems help crews navigate even the most densely built neighborhoods, while coordination with police, hospitals, railway operators, and utility companies allows multiple organizations to work together without unnecessary delays.
During large-scale emergencies, command centers become information hubs where decisions affecting millions of residents may be made within minutes. The technology supporting those decisions is impressive, but equally important is the extensive training that allows people from completely different organizations to communicate using shared procedures long before an actual disaster occurs. One of the less visible systems supporting Tokyo is the city's extraordinary culture of routine maintenance. Around the world, infrastructure often receives attention only after visible problems begin appearing. Tokyo follows a different approach whenever possible. Bridges are inspected before cracks become dangerous. Railway components are replaced before they reach the end of their expected service life. Water pipes are monitored continuously instead of waiting for major leaks.
Escalators, elevators, electrical substations, ventilation equipment, flood pumps, communication towers, and countless other pieces of infrastructure are maintained according to detailed schedules that prioritize prevention over repair. This philosophy may appear expensive at first glance, but it dramatically reduces the likelihood of catastrophic failures. Small problems are usually easier, faster, and less costly to fix than major breakdowns that disrupt entire systems. Behind the scenes, thousands of maintenance workers begin their shifts every day knowing that their greatest success will likely go completely unnoticed. If they perform their jobs perfectly, the public simply experiences another normal day. Technology has made predictive maintenance even more effective. Sensors installed throughout the city constantly measure vibration, temperature, electrical performance, structural movement, humidity, water pressure, equipment wear, and countless other variables.
Artificial intelligence and advanced analytics help engineers identify subtle patterns that human observers might overlook. A transformer showing slightly unusual temperature fluctuations may receive inspection before it fails. A bridge experiencing microscopic structural changes can be examined long before drivers notice anything unusual. Railway wheels can be replaced based on measured wear rather than waiting for visible damage. These systems do not eliminate human expertise. Instead, they provide technicians with earlier warnings, allowing repairs to be scheduled before disruptions occur. In many cases, residents never realize that maintenance was even necessary because the work is completed quietly during overnight hours or carefully coordinated closures. Perhaps the most remarkable hidden system, however, is not technological at all. It is the collective behavior of the people living in the city.
Tokyo functions partly because millions of individuals follow routines that reduce unnecessary strain on shared infrastructure. Commuters naturally form orderly lines before trains arrive. Passengers allow others to exit before boarding. Residents separate waste according to detailed recycling guidelines. Businesses cooperate with delivery schedules designed to reduce congestion. During emergencies, people generally follow official instructions rather than creating panic. None of these individual actions seem particularly significant on their own, but together they reduce friction across nearly every major system. Engineers can build resilient infrastructure, but human behavior often determines whether that infrastructure performs as intended under pressure. The city's remarkable efficiency is therefore not created solely by machines, software, or engineering.
It is reinforced every day through millions of small decisions made by ordinary people who rarely think of themselves as part of the infrastructure. Yet, without that widespread cooperation, many of Tokyo's most sophisticated hidden systems would become far less effective, proving that the city survives not only because of what has been built beneath its streets, but also because of the habits practiced above them every single day. As remarkable as Tokyo's infrastructure is today, perhaps its greatest strength lies in the fact that it is never considered finished. Every hidden system is constantly being evaluated, upgraded, expanded, and redesigned to prepare for challenges that have not yet fully arrived. Population changes, climate change, aging infrastructure, evolving technology, and shifting patterns of energy consumption are all forcing planners to rethink how the city will function decades from now. Unlike cities that simply react to problems after they become unavoidable, Tokyo often begins preparing years before those pressures become visible to the public. Engineers know that many of the systems operating today will eventually need replacement, not because they have failed, but because the city itself is constantly changing. Every new skyscraper, residential development, transportation project, and industrial facility adds another layer of complexity to a network that is already among the most sophisticated on Earth. Maintaining balance inside such an enormous machine requires continuous adaptation rather than permanent solutions. One of the biggest challenges facing Tokyo is its changing population. Japan's demographic trends are unlike those of many other major countries. The average age continues to rise, while the number of younger workers gradually declines. This affects nearly every hidden system that keeps the city running.
Public transportation must accommodate an increasing number of elderly passengers. Hospitals and healthcare facilities face growing demand. Utility companies must replace experienced technicians who are reaching retirement age. Construction firms compete for skilled workers capable of maintaining aging infrastructure. Even emergency planning evolves as communities become older. A city built around millions of healthy commuters moving quickly through railway stations must also prepare for larger numbers of residents who may require additional assistance during emergencies. Technology helps fill some of these gaps through automation, robotics, and remote monitoring, but human expertise remains impossible to replace entirely. As a result, Tokyo is investing heavily in training the next generation of engineers, maintenance specialists, emergency responders, and infrastructure operators whose work will remain largely invisible despite its importance.
Climate change presents another challenge that reaches into nearly every corner of the city's hidden systems. Summers have become hotter, placing greater demand on electrical grids as air conditioning usage increases across millions of homes and offices simultaneously. More intense rainfall events require drainage systems capable of handling larger volumes of water in shorter periods of time. Rising temperatures affect railway tracks, road surfaces, electrical equipment, and building cooling systems. Coastal infrastructure must also consider long-term changes in sea level and stronger storm surges. None of these problems can be solved independently because each one influences several other systems. More electricity demand requires stronger transmission networks. Larger flood protection projects require additional pumping capacity and emergency power. Increased cooling needs affect water consumption while also placing greater pressure on energy production.
The city therefore approaches climate resilience as an interconnected challenge rather than a collection of separate engineering projects. Technology continues transforming how these hidden systems communicate with one another. Thousands of additional sensors are being installed across transportation networks, bridges, tunnels, water systems, electrical substations, and public facilities. Artificial intelligence is becoming increasingly capable of identifying subtle patterns that might indicate future equipment failures, unusual energy consumption, changing traffic conditions, or developing infrastructure problems. Digital twins, virtual models that continuously mirror real-world infrastructure using live operational data, allow engineers to simulate disasters and test possible responses without interrupting actual services. Instead of waiting for equipment to fail, operators can increasingly predict maintenance needs weeks or even months in advance.
Traffic management systems can respond dynamically to accidents. Water networks can detect pressure changes almost instantly. Electrical systems can isolate damaged equipment automatically before failures spread across larger sections of the grid. Every year, more decisions are supported by information flowing continuously between systems that once operated almost entirely independently. Yet despite all this technology, Tokyo still depends on something far simpler than computers or engineering. It depends on trust. Every morning, millions of people leave their homes believing that the trains will arrive, the elevators will work, the water will be clean, hospitals will be ready if needed, emergency services will respond, grocery stores will have food, traffic signals will function, and electricity will continue flowing through the countless wires hidden behind walls and beneath streets. That trust allows nearly 40 million people to organize their lives with extraordinary confidence.
Businesses schedule meetings months in advance. Manufacturers coordinate production down to the hour. Families plan their daily routines around transportation systems that are expected to perform with remarkable consistency. Visitors quickly adapt to an environment where reliability feels almost ordinary. Few stop to consider how much invisible work is required to preserve that sense of normality every single day. In the end, the greatest hidden system keeping Tokyo alive is not a single tunnel, power station, railway, flood barrier, or communication network. It is the way thousands of independent systems have been designed to support one another when conditions become difficult. Electricity supports water. Water supports healthcare. Transportation supports food distribution. Communication supports emergency response. Maintenance protects transportation. Logistics sustain businesses. Human cooperation strengthens every layer above and below the ground. None of these systems could keep the city alive on their own. Their true strength comes from the countless connections linking them together into one enormous living network. Most people experience only the visible result: clean streets, reliable trains, stocked stores, illuminated skylines, and an extraordinary sense of order. Beneath that ordinary routine, however, lies one of the most complex urban survival systems ever created. Every second, thousands of people make decisions that most residents will never notice. Every minute, millions of individual components continue performing their roles without recognition. And every single day, while nearly 40 million people simply go about their lives, an invisible city beneath the visible one